Well, how are heart rate and breathing rate related? Well, we've studied heart rate before, ECGs, pulse, things like that. So let's say this is a breathing. And for one thing, breathing is much slower than heart rate. You'll have 15, 20, 25 breaths per minute, whereas you'll have 60, 70 sometimes heartbeats per minute. So you take a look at this and you going to see something actually kind of interesting. When we look at pulse here, you'll see when you breathe in, this pulse actually is a little more rapid, and then it slows down, and then it gets rapid again. And I'm exaggerating a little bit here, but what we're seeing here is that during inhalation, you seem to have this tachycardia, where it goes a little bit quicker than during exhalation between breaths. And it's called sinus arrhythmia, and we don't always see it when we look for it in lab. It can be subtle and depends on the person. But what's really going on here is that the control of breathing and heart rate are right next to each other in your brainstem, in the medulla, and a little bit in the pons. And when you take a breath, it actually inhibits the vagus nerve that goes to your SA node in your heart. And remember, the parasympathetic vagus nerve is going to normally put some brakes on the heartbeat, right? So if you inhibit that, it's going to pull up on the brakes and allows the heart rate to be a little bit quicker during inhalation. And that's when the signal goes to your diaphragm to begin the breathing. So the sinus arrhythmia is a cool little trick that we can see sometimes. The second question here is, what happens to your heart rate during breath holding, when you hold your breath? And think about, what would you expect? I mean, I can see an argument where you're holding your breath, and so therefore your heart will beat faster because it feels like it's starved of oxygen. It needs to really, step up its game. But it's actually the opposite usually. And again, this is highly variable. But what we'll see is that here's breathing, and then breath holding. You're holding your breath. You will see. Here's your pulse. Drawing it kind of quickly. But what you'll often see is that the pulse will slow down. And more than that, I see the pulse amplitude really gets less. And then it'll come way back up again as you start breathing again here. But yeah, right here, during breath holding, you often see that your heartbeat is depressed. And so especially the pulse amplitude, and also it slows down. So there's a mammalian diving reflex where when we put our faces in cold water, our heart automatically slows down. The pulse will go down. So that, I think it's a compensating mechanism so that we can conserve energy during diving. So pretty cool little trick there.